Hello and welcome to my YouTube channel. Today in this presentation, we are going to learn the fundamentals of UART communication, and then we will use the concept of UART and implement a project in which we will print the data of ADC on the UART module. So first of all, let us briefly talk about the concepts related to UART. So UART basically stands for Universal Asynchronous Receiver Transmitter. So this is nothing but a simple hardware communication protocol used for asynchronous serial communication. So the word asynchronous here implements or tells us that this particular communication protocol is not dependent on clock cycles of a microcontroller or microprocessor. UART is generally used for transmitting and receiving data between devices, generally one-to-one, such as microcontrollers, computers, and other peripheral devices. Like I said, the word asynchronous here represents that UART protocol does not use a clock signal. Instead, this particular communication protocol relies on timing between sender and receiver to align data transmission. So that means in the very beginning we will have to set a particular communication rate between the transmitter and the receiver, and then the system or the UART will not use clock for transmitting or receiving the signals. Instead, it will work on the predefined timing between the receiver and sender. Now let us talk about the data frame structure. In UART, generally the start bit starts the communication. Data bits can be of 7, 8 or 9 bit long, representing the actual data. So depending on the configuration in UART, we can have 7 bit, 8 bit or 9 bit message. Then we have parity bit. Based on the type of parity, we can use the parity bit. For example, if the parity bit is even, or if the system is even parity, then the number of ones in the message should be even, otherwise the parity bit will be 0 or vice versa. So this is an optional bit used for error correction or detection, and this can be, like I said, even or odd parity system. In the last, we can have stop bits, which will be 1 or 2 bit long depending on the user's configuration. Baud rate defines the speed of communication between the two devices, generally measured in bits per second or BPS. So in the configuration, we have to decide, or we have to configure the baud rate between the sender and receiver. UART is very simple configuration and it is cost effective and versatile. Now let us talk about the technical details related to UART. So baud rate determines the speed of transmission, or we can say speed of communication. Common baud rate includes 9600 or 115200 BPS. Now, data frame rate, like I said, start bit generally is 1 bit long. Data bit can be 5 to 9 bit long, generally 7, 8 or 9 bit long data bit. Parity bit can be 0 or 1, it is optional, and stop bit generally is 1 bit or 2 bit, and in some cases some devices allow 1.5 bit long stop bits also. For handshaking, or we can say for synchronization purpose, UART can be configured with or without hardware flow control. So X on and X off, okay, is one of the configurations by which we can control the data. Secondly, we can have hardware based data control or data flow control, which is configured by using RTS and CTS. For this we will have to use extra lines, but generally we don't use these lines. For error handling, there can be frame error, overrun error and parity error. So frame error occurs if expected stop bit is not detected. So if there is a missing stop bit, then we can end up with frame error. Overrun error generally occurs when the receiver buffer is full and new character arrives before the old one is read. So generally overflow we can say, or overrun error. Parity error occurs when there is a mismatch between the expected and actual parity bits. So typical applications involve embedded systems, PC or computer interfacing and networking. In networking, we generally use RS-232 and RS-485 communication standards, which are basically controlled by UART. So key considerations we have to keep in mind: the signal integrity and the distance to speed trade-off. So when we talk about signal integrity, proper circuit design must be maintained, and there is a trade-off between the distance and the speed of communication. So for longer distance, always use lower baud rate. For shorter distances, we can use higher baud rates. For longer distances, we cannot have very high baud rate because that will end up with error in the communication. Now let us try to understand the connections that we have to make in UART. So suppose we have device 1 and device 2, both have UART module. Then in UART module, we will get one TX line, one RX line and ground line. So we need only 3 lines, basically 2 lines, TX and RX, and we connect TX of one device to the RX of another device, and similarly TX of second device will be connected to the RX of first device. And for common voltage level, the ground pins should be connected together. So this is a very simple connection. We need only 3 wires, TX to RX connection and then ground connection. Let us look at the frame or data frame rate or data frame structure. Generally, in UART, the line remains high and that is considered idle. So the line will remain high until unless communication starts. And then a start bit will be initialized, and that will be always making the high line to low. So the transition will take place from high to low. That will inform the system that start bit has arrived. And then after that, when the communication is complete, there will be a stop bit which will be transitioning from low to high. And then, like I said, we can have parity bit in the system and 7 or 8 or 9 bit data bits, or we can say the message bits. Generally, zeros represent low signals and 1 represents high signals. And once the stop bit is received, then the system again goes to idle state. Remember, the least significant bit follows the start bit, and most significant bit is generally before the parity or stop bit. And after stop bit, the system again enters into the idle state. Again, if you want to send any message, then the line has to come from high to low. That will inform the system that there is another start bit. So this is generally the frame structure of the UART. Stop bit can be 1 bit, 1.5 bit or 2 bit, but in most cases you will find 1 or 2 bit stop bits. Now coming to the ASCII values. For example, in UART, whenever we transfer any message, generally we transfer those message in ASCII character. For example, if you want to transmit A from one device to another device, then equivalent value of A is 41 in hexadecimal, and in binary it is represented by 01000001. So we can cross check all the messages by using ASCII table. So if we have the ASCII table with us, then we can cross check all the messages using the UART protocol, or we can use logic analyzers to demodulate or reconstruct all the message signals. Common baud rates which are prescribed for UART communication are 1200, 2400, 4800, 9600 and so on. So we have to configure the baud rate prior to the beginning of communication. And in general, in the past we used to use these RS-232 cables to connect between two different devices, and these RS-232 connectors or cables generally used UART communication. Now let us talk about the connections that we will be needed in our project. We will be using the same temperature sensor LM35. We will be connecting the VCC, ground and analog signal to 3.3 volt, ground and A1 channel like we did in the previous videos. And with this I would like to end the presentation. In the next video I will talk about the codes which are required to implement in STM32F446RE to start the UART communication, and in that we will be printing the value of temperature on the UART console. If you have not subscribed my channel, then I would request you to please subscribe the channel and press the bell icon so that you will get the notifications as soon as I upload a new video. If you have any suggestions or comments, do share your suggestions and comments in the comment section. Thank you and have a nice day.